Now you remember that if x is equal to y, then log base a of x is equal to log base a of y. To solve exponential or log equations, remember you want to always isolate your exponent and your log. To undo exponents, you're going to want to take the log of both sides. To undo logs, you're going to want to put it in exponential form. Once you have the logs equal, then you can set the arguments equal and solve algebraically. For more complicated problems, you may need to solve around a little bit, and then make sure you always check your answers. So solve x to the 8 is 21, and let's give it in the nearest thousands. So the first thing you want to do is, you can't find a common base here, so just take the natural log of both sides. So this becomes x times natural log of 8 is equal to natural log of 21. So x is natural log of 21 divided by natural log of 8, or about 1.464. Now, suppose I want to solve 5 to the 2x minus 3 is equal to 8 to the x plus 1. I want to take the natural log of both sides, and then the exponents are multiplied out front. So I have 2x minus 3 times the natural log of 5 is equal to x plus 1 times the natural log of 8. I'm going to distribute my constants because those natural logs are just numbers. I'm going to collect my x terms on one side and my constant terms on the other side. Factor in x out of both terms on the left. Now I divide. This is an exact answer and what I will require of you on the test. But if you were to use a calculator, you'd get about 6.062. So solve e to the absolute value of x is 50. So I want to take the natural log of both sides. So the absolute value of x is equal to the natural log of 50. So x is plus or minus 3.912. So my solution set is plus or minus 3.912. Now suppose I want to solve e to the 4x times e to the x minus 1 is equal to 5e. The first thing I want to do is gather all my e's to one side. So on the left, I can combine e to the 4x times e to the x minus 1 to e to the 5x minus 1. But now I need to get this other e to the other side. So I'm going to divide by e. So I have e to the 5x minus 2 is equal to 5. Now I want to take the natural log of both sides. That will give me 5x minus 2 is equal to log of 5. And now I solve for x. So x is log of 5 plus 2 over 5. To round to the nearest thousands, you need a calculator, and it's 0.722. Now suppose I want to solve something like this. E to the 2x minus 6 e to the x plus 5 equals 0. Now I notice I don't have the same powers of e, and I can't exactly combine them. What I can do is I can do a u substitution, where u is e to the x. So this is u squared minus 6u plus 5 is 0. This I can factor into u minus 1 times u minus 5 equals 0. So u is 1 or u is 5. But remember, u is e to the x. So substituting back, when u is 1, e to the x is 1. So in this case, taking the natural log of both sides, I get x is 0. Now when u is 5, e to the x is 5. I take the natural log of both sides. So x is the natural log of 5. So my solution set is 0, natural log of 5. Now let's solve these equations. Natural log of x is 36. Divide through by 4, so the natural log of x is 9. Put it in exponential form. X is e to the 9th. I want exact values, so leave it that way. Log base 3 of x cubed minus 5 is 1. We're going to put it in exponential form. Add 5 to both sides, so x cubed is equal to 8. So x is a cubed root of 8, so x is 2. My solution set is 2. Solve log of 2x plus 1 plus log of x is equal to log of x plus 8. So the first thing we want to do is use the product property to get the logs combined. And now I can distribute the x out within my um, left term here. Now I can use the property of logs that log of a equals log of b if a equals b. So now I have a quadratic, and I can get x is plus or minus 2. You must check these. If I check it, I see that I cannot put a negative 2 into the log of x. So the only valid solution is x is equal to 2. So suppose I want to solve log base 3 of 4x plus 1 times x plus 1 is equal to 3. I want to get rid of the log, so I'm going to write it in exponential form. So 4x plus 1 times x plus 1 is equal to 3 cubed. So now I have a quadratic, and I'm able to factor this into 4x plus 13 times x minus 2 equals 0. So x is minus 13 over 4 and 2. Now remember, you need to check the arguments to make sure the original uh, statement is still true. In this case, they are. Now solve log base 2 of 2x minus 5 plus log base 2 of x minus 3 is 3. Well, the first thing you need to do is combine your logs, write it in exponential form, and now you have a quadratic. Go ahead and solve your quadratic. So you're getting 11 plus or minus the square root of 65 over 4. Now, the negative solution makes the 2x minus 5 negative, so you can't have that solution. So your answer is 11 plus the square root of 65 over 4. Suppose I want to solve natural log of e to the log of x minus log of x minus 4 is 5. Well, we're going to try and simplify this down a little bit if we can. Natural log of e to the log of x is just the natural log of x. And then minus natural log of x minus 4 is equal to log of 5. Now I want to combine. So this becomes natural log of x divided by x minus 4 is equal to natural log of 5. I use properties of logs now to say that x over x minus 4 has to equal 5. Clear my fractions, solve for x, so I get x is equal to 5. The equation T is T naught plus C e to the minus KT is using Newton's law of cooling. So if I want to solve this for K, I'm going to subtract T naught to start with. And I'm going to divide through by C. I'm going to take the natural log of both sides. So minus KT is natural log of T minus T naught over C. So to keep solving this for K, I'm going to need to divide by minus 1 over T. So here is another table that gives US tablet sales in millions for several years. And the modeling, we can model the function by f of t is 20.57 natural log of t plus 10.58, where t is the number of years after 2009. Use the function to estimate the number of tablets sold in 2011. In the year 2011, t is equal to 2. So f of 2 is 20.57 times the natural log of 2 plus 10.58, or about 24.8. So this is actually really pretty close to the actual number. If this trend continues, approximate when the annual sales will reach 58 million. So let ft equal 58. We're going to solve it for t. So 58 is 20.57 natural log of t plus 10.51. So I'm going to subtract the 10.51, divide by 20.57, and raise to the e power. When I do that with my handy dandy calculator, I get t is 10.1. So adding 10 to 2009 gives the year 2019. So we will hit 58 million sales in 2019.